Just last week, I was on a call with the CTO of Ron. We had just deployed a rack solution for them about 2 weeks ago, and then he said, "Hey, when does this thing actually start learning? Want it to get better with time. We want it to get smarter." Most companies assume that the way to make rack systems smarter and better over time is fine tuning. But that couldn't be further away from the truth. I'm Rohan Sawant. I run IONU. We help companies adopt AI. And in this video, I'll show you how we actually develop and build and deploy self-learning rack systems in production for our clients. Here's what actually happens in the real world. You deploy your RAG, users ask questions. Sometimes it nails the answers and sometimes it doesn't get them right. But users expect it to remember and to learn and to not make the same mistake again. And they think fine tuning is the answer to that. But this is not really a thing. Most enterprises don't need a fine tuned model or they don't need a custom LLM. What they actually need is a smarter, more comprehensive and extensive knowledge base. The real pain point isn't really the model performance, it's just the constant rejections, and I don't know how to answer that responses. Every time your RAG answers a question, you add a simple thumbs up or thumbs down button. When the user thumbs up an answer, we create a new record, the exact question they asked and the answer that the system gave. This goes straight in the vector database as a new question and answer pair. Step 2, the next time someone asks the same question or a similar question, guess what surfaces first? That verified answer. So now your RAG system learned a new fact without actually needing to do any fine tuning at all. Now, whenever a user thumbs down a response, we prompt them with something like this: "Hey, if this is not the right answer, what should the right answer be?" Then we expect them to provide the correct information, and then this gets added to the knowledge base. This way, the system will never make the same mistake twice. On the technical implementation side, the feedback collection system is just a thumbs up or thumbs down UI and nothing fancy. In step 2, for the verification pipeline, we have to remember that not every user correction is going to be accurate. You might want a human review or at least track which users consistently provide good corrections. For step 3, for the dynamic knowledge base update system, this is where you append a new Q&A pair to your vector database. The key trick here is to tag these as verified or user contributed, so you can weigh that higher during retrieval. In the recent past, when we have implemented these systems, we often make it a point to store the original question and the system's answer and the user's correction and metadata like timestamp and the user ID. This lets you essentially audit and then roll back changes if needed. If a document or a data source consistently leads to corrections, maybe it needs updating. Additional checks and balances can also be implemented to prevent the system from getting gamed, and periodically measuring the knowledge drift of the entire system is important to make sure that the final answer and the final system aligns with the source of truth. With all of this said, you now will be able to track rejection rates to see how often your system says "I don't know." And with time, you should probably start seeing these numbers go down. So this is how you build a self-learning RAG system. You don't need to fine-tune the model. You don't need to retrain it. All you need to do is a smart feedback loop on your knowledge base, which just continuously keeps it updated. That's self-learning RAGs.